Good day. As you can see, we're looking at separation techniques. And it turns out all the examples we're looking at here will be in showing physical changes. A magnet can be very useful for separating out a mechanical mixture. So if you have a bunch of solids together and one of those solids happens to be magnetic, then bringing a magnet nearby, you can extract those materials. Physical change. Often we'll make a cloudy mess when we mix chemicals together, and the solid that doesn't dissolve is called a precipitate. If we just let it sit, it might sit for an hour, it might sit for a day. Whatever's denser will settle on the bottom. So if the solid's denser, it will settle at the bottom and we'll end up with a liquid above it. So that's a very straightforward way to do it. Things called flotation, based partly on different densities. Oil and water don't mix together, and that's to do with difference in polarity. Oil tends to be is a non-polar material, whereas water is a polar material, and polar and non-polar materials do not mix. Quite common for us to use filtration, and so filtration really is speeding up the settling process. So we're taking our filter paper in a funnel, and the bits are too big to pass through the filter paper, get trapped here. And what comes through is called the filtrate. Not too surprising there. Lovely name here, residue, for what we trap in the filter paper. We have something called extraction. And then we have fractional distillation. And what that means is we're heating up our mixture here. And let's say it's a mixture of liquids. Well, the liquids probably have different boiling points. So ones with a lower boiling point will evaporate first and condense out first. And ones with a higher boiling point will condense out later and come out later. If we had any solid that was dissolved, it would be left behind here as a residue. So those are all examples of physical changes. Hopefully it makes sense how a condenser works. It's quite a fun apparatus to set up. So you're going along here, and what you have is you've heated materials. You can have a sealed system, but outside you have this jacket that allows cold water to be pumped around, and that's what condenses the gas back to a liquid. So when you're pulling here, you're going to get a liquid component arriving there. You might remember doing a distillation lab way back when. Crystallization. So you simply have a mixture and you let the solvent evaporate away and you're left behind with crystals. And the slower the evaporation, the longer the time you have to form, the bigger the crystals are you'll get. Now you're going to do a chromatography lab and you're going to use chromatography paper. And this will be an interesting, ours won't look exactly like this. There are actually all kinds of different chromatography, but we're going to use paper chromatography in our first lab in this course. And right away that's telling you it's going to be a physical change because we're separating a mixture.